We're thrilled today to have Dan Dennett be able to join us for a short interview as part of today's announcements. And so, Dan, welcome. Could you maybe give a brief introduction to yourself and an overview of your highly acclaimed, influential work?
Well, I came to Tufts way back in 1971, and aside from visiting years one place or another, I've been there ever since. And I'm in the philosophy department. That's my official field is philosophy, but I branched out a lot, and for years have been working with people in artificial intelligence and in neuroscience and in psychology, cognitive science. So I'm co-director of the Center for Cognitive Studies, and over the years I've written a lot of books, a lot of articles, hung around a lot of laboratories, messed with a lot of software, and studied evolution quite a lot, both by reading books and talking to theoreticians and occasionally getting out in the field to see what nature's really like.
Well, that your interest in field work and experimental work is one of the great features of your work. So we've both been at Tufts a long time. What do you think is one of the most important changes you've seen over your time at Tufts?
Yeah, well, when I came to Tufts, we didn't have any computers. Oh, we had one or maybe two, and now we have some really world-class computational research going on by world-class people, and the field has grown, and of course, cognitive science has grown too. When I started at Tufts, behaviorism was still in its death throes, and people were trying to figure out how to be cognitive, but it took a little while before things got more or less ironed out there.
We're partly drawn here today because of Jeff Steibel's contributions and recent donation to the university. Can you say a little bit more about your relationship to Jeff, and do you have any particularly good stories that you might share with us?
Well, Jeff was a student of mine, an undergraduate student of mine, and so I'm delighted to have a student of his caliber come back to Tufts in this way. So it's a nice way to see the circle closed.
So what do you think will be one of the more important or long-lasting consequences of Jeff's recent donation to the university? Do you think it will be the named professorships, or the BrainGate technology, or the creation of the Steibel Dennett consortium, or some other area that we're not anticipating?
Well, I think they all go together, and I don't know how to portion out what may happen where. I think the main thing is going to be getting researchers a little elbow room to work with each other and develop interdisciplinary projects, and the professors, of course, will help with that. I'm delighted to see Gina Cooperberg named to the professorship, because she's a very both talented and open-minded and multidisciplinary, and it really makes a big difference. So I'm delighted for her to have the chair. I think that we're in a sort of speed up right now, as so many things in this world are. Everything's happening faster and faster. And I think the developments in cognitive and brain science are piling up faster than we ever dared hope. So there's an awful lot of work to do. It's a very exciting time to be in cognitive science.
So you've brought up an important transition, and that is, I mean, humanity is sort of virtually defined by our technology, right? Since the creation of stone tools on the plains of Africa at the dawn of humanity, we have been one and one with our technology, and now it seems like there's a deep and increasing connection between the human brain and technology, and certainly BrainGate, similar technologies seem to be breaking down one of the last barriers, which is the direct connection of the brain to the computer. So what do you think might be one of the benefits of this type of direct brain computer interaction? What might you be seeing in the future?
Well, a lot of the benefits will be not so much for us on the research end as for people in the world who will find their jobs easier because they won't have to push as many buttons and turn as many levers and dials because of a simple brain link which will enable them to do that. Now, that in itself, I don't think is a revolutionary development. For hundreds of years, people have used hand tools to understand the world, to feel the world. The blind man's cane is a fine example. It's as if his fingers extended right out to the road. You can tell textures and all kinds of things like that. So I see the direct brain prosthesis interface as not a revolutionary development, but as a more gradual development, but a very important one. And which aspects will reign? Interesting question. One thing I'm actually worried about is who's going to be in control. Attention is the key to control. Who controls your attention controls you to a surprising degree. And right now, there are many agents, many corporations, many activities in the world that are dead set on controlling your attention on your smartphone, on your computer. And for me, one of the most important things we have to do is learn to protect our own attention from these lures, from these attractors, because they're very dangerous and they're tremendously potent. We don't want other people pulling our strings and turning us into puppets. We've got to control our own strings, and that takes some serious work. And I guess one of the things I would really like to see is technology which helps the individual empower herself or himself to keep those attention draggers at bay and help us concentrate on what really needs to get done. If we can do that, we will have a wonderful invention.
Yes, there's no doubt. Spotify, Google, Netflix have increasingly smart software and technology that it certainly influences my choices, right? And it's sometimes just too easy to let this technology take over and use my personal data to make those choices for me. So, do you see, besides the control of attention, do you see other concerns about letting increasingly more autonomous machines and software influence our individual choices and other parts of society?
Absolutely. I think one of the reasons as a philosopher that I'm so much engaged in this field is that I think it raises important ethical issues, social issues. I think it's hard to overemphasize the effects this can have and the ways in which these technologies and the political power and corporate power behind them threaten many things that we hold dear. I think we should be extremely vigilant about these technologies, and also at the same time, we should be looking for ways to use the technologies to protect us from them. It's a sort of iterative process. When many years ago, when George Smith and I here at Tufts started the curricular software studio, we said, look, there's two ways that a computer can give you power. There's the bulldozer way and there's the Nautilus machine way. The bulldozer way, you're still a 98-pound weakling, but you can move a hill. The Nautilus machine is a technology which makes you personally stronger. And our goal at the software studio was to create, in effect, Nautilus machines for the mind. And I think that's a project that we should resume full bore now, and think about ways in which we can harness this fabulous technology to strengthen our own ability to avoid the junk and the misuse of time that the rest of the technology is trying to induce in us.
So let's shift gears a little bit. And Mike Levin is one of our distinguished panelists today, and I know you've been collaborating with Mike recently. Could you say a little bit about this work? I know it cuts across some of your past thinking about the brain, and I know it has connections to Mike's area of expertise in developmental biology. And at least I know one paper that's coming out has the intriguing title of "Some Assembly Required." Do you want to say a few words about that collaboration and what you think some of the implications of it might be?
When Mike Levin showed up here at Tufts a few years ago, he got in touch with me right away and said he wanted to come to my lab meetings. Well, I didn't have really lab meetings, but I had meetings with my postdoc and graduate students. He joined in some of those. And what particularly interested him was an idea that I've been developing for 50 years, I guess, the idea of intentional systems, the intentional stance, the idea of a perspective we can take on things where we treat them as agents with desires and beliefs, and then we can try to trick them, we can try to cajole them, we can see, what moves them, and it's often a wonderfully predictive and handy crutch for figuring out how they work. If you want to induce pathology in a mechanism, assume it's a really good working mechanism and then try to get it to do something that it shouldn't be doing, and then you figure out how the trick is actually done. And that's just what he's been doing with developmental biology, right down there at the molecular level, with spectacular results. And he's run into something that I've found in other fields, which is a sort of residual and irrational phobia about using intentional language, using purpose talk and intention talk to talk about biological phenomena. One is supposed to abjure that. In a way, it's as if large parts of biology have not gotten over behaviorism, and they're still trying to tie their hands behind their backs and not use any of the naughty mentalistic words. And what Mike and I say is, no, relax, chill. If you use them carefully, they're a great help. They illuminate circumstances. They let you see the woods for the trees. They are as useful in understanding the complexities of development as intentional terms in cognitive neuroscience are in understanding the complexities of the brain. If you can't talk about information flow and signaling in the brain, forget it. And the same thing turns out to be true in developmental biology.
But the argument is not that the individual cells that are making up the creature as it's being developed, or I guess the individual cells, are not to say that they have intentionality, but this is just a good theoretical framework for observers to try and understand what they're looking at.
There's no sharp line between the literal and the metaphorical here, and we shouldn't worry about finding some magical line which says above the line it's literal. Those are real beliefs, those are real minds, and below the line it's not literal. I think Mike and I agree. Mind goes right down to the very first microorganisms that ever managed to reproduce. And think of it that way and recognize that the minds we have, human minds, are very strange and over-elaborated versions of all the kinds of minds down below that.
So as we're thinking about these different qualities of mind, and we think about the human mind, I guess, what do you think? Do you think language is one of the critical steps in that development that begins to move us in the directions where we do technology and some of the kinds of things we were talking about earlier?
Oh yes, in fact, I think it's language that creates the human mind, and that makes human minds really importantly distinct from all others. I just said that there's a sort of continuum of minds, and so there is. But if you want to see a giant step in that continuum, it was the birth of language, because language makes possible self-control in ways that are not available to other organisms. We can remind ourselves of things and cajole ourselves and make rules for ourselves and talk it through, and we can talk to ourselves. Talking to yourself is a very important kind of thinking. And no other organism can do that. No other organism can compare notes with a conspecific either. And these open up by orders of magnitude the range of things that we can think about. So language indeed makes a huge difference.
Well, Dan, thank you for taking this time today to talk with us and to share your insights about BrainGate and technology. And and just from me personally, I just want to thank you for all your contributions to philosophy, neuroscience. It's a remarkable career that you've had, and all of us have really benefited from your thinking.
Thank you, Bob, and I've enjoyed all my interactions with all you folks. I mean, Tufts has been a great place to work over the years. I wouldn't trade it for anything.
All right. Thank you very much.
Thank you, Bob.